morning, fourth graders. Today in math, we're going to take a step back from fractions and we're going to talk about decimals a little bit. What I've created here is a place value chart, similar to the one that we had on the board at the front of the classroom above the whiteboard. So I'm sure you're very familiar with these place values over here from the ones, tens, hundreds, and thousands, because these are the ones that we work with most often. Today, we're going to take one step farther. After the ones place, we always see a decimal, and then the next place value is called the tenths, then the hundredths, and then the thousandths. These place values over here are all pretty small and they're all worth less than 1, whereas everything over on the opposite side is greater than 1. I want you to pay attention to the ending of these words as well. So on the left side of the ones I have tens, but on the right side, the only difference between this word is it has a little th at the end of it. So it's almost like we're spraying a little bit when we say tenths. Same thing with hundreds. Over here I have hundreds, but then on the decimal side I have hundredths. And then on the left side I have thousands, and on the decimal side I have thousandths. So the place value goes in the same order, just opposite, and at the end of each word there's a th added, and that's how you know that it is the decimal place value and not the larger place value. So, for example, if I had 1.4, I would read that number 1 and 4 tenths. All right, so whenever you get to the decimal, you say the word and then you read the number that you see to the right just the way you see it, and then you say the place value of the last digit. So for example, this would be 1 and 4 tenths. Let's try a different example. Let's try the number 21, and here I would read this whole number 46, and then I would say the place value of the last number. So 21 and 46 hundredths. Let's try one more example. I could have 14 and when I go to read this, I'm going to read this whole number 201 thousandths. So this number says 14 and 201 thousandths. Now, when we're comparing decimals, which is what we're going to be doing today, you need to remember that when you're looking at a number line or you're looking at place values, like you see here, the farther you go to the left, the more a number is worth. So the bigger a number is. And the farther you go to the right, the less a number is worth, or the smaller it is. So for example, if I asked you to compare 4 tenths to 4 hundredths, and I asked you which one is more, well, 4 tenths would be right here, and 4 hundredths would be right here. So you can see 4 hundredths is smaller because it goes farther to the right than 4 tenths does. So 4 tenths would be greater than 4 hundredths. All right. A great way to think of this is thinking about money. We deal with money and coins all the time, and that's a great way to think when you're comparing two decimals. All right, in some of your problems today, they're going to ask you to compare numbers, and it might be kind of confusing when you're looking at them. For example, you might be asked to compare something like 54 hundredths and 6 tenths. Now, normally when we look at two numbers like this, we might want to naturally say that 54 hundredths is bigger because 54 is larger than 6. But my strategy when I'm doing this, I always would recommend that you stack these two numbers one on top of the other. So if I were to stack 0.54 on top of 0.6, then I can compare them by place value. And when you're comparing by place value, you always want to start at the left and go over to the right. So if I compare the ones place, they both have a 0 in the ones place. My decimals are stacked up. And then I'm going to compare the tenths place. Here I can see that the bottom number has 6/10, and 6/10 is bigger than 5/10. Now you might be saying, but the top number has a 4 in the hundredths place. That's true. Technically the bottom number has a 0 placeholder down there. If we were comparing these numbers and we were thinking of money, this would be like comparing 54 cents to 60 cents. Well, 60 cents is definitely larger than 54 cents. So don't let something trick you just because it might look smaller. Make sure you take the time to either stack up the numbers or think about what each place value is actually worth in each of these problems. So let's go over the first couple of problems together, and then you can pause the video and try the rest on your own. So question number 1 asks us to compare the decimal 3/10 and 2/10. Here I can see they're both in the same place value. They're both in the tenths place. So I'm going to ask myself, what is larger, 3 or 2? Well, it's worth more to have 3 of something, so 3/10 is larger than 2/10. Another way to think of this is 3/10 is technically like saying you have 30 cents, whereas 2 cents is technically like saying you have 20 cents. Which of the two would you rather have? I would rather have 30 cents. So that is what you're doing for the left side of these problems. On the right side, you're taking the 3 numbers that are listed and you're putting them in order from least to greatest. So looking at the number 8/10, 2/10, and 5/10, and I want you to be really careful. The decimal is right here, and the number after, or the symbol that you see after the 8 and after the 2, that's just a comma separating those. So don't let that confuse you. We're looking at the number 0.8, 0.2, and 0.5. So to put them in order from least to greatest, the smallest number is going to be 0.2 or 2/10, and then 0.5 or 5/10, and lastly 0.8 or 8/10. And this works because they're all in the same place value. They're all in the tenths place. So because they're all in the same place, I just need to put them in order from smallest to biggest. And that's what you're going to be doing on the right side of this page. Be really careful on questions like number 11 because they're going to try and confuse you by adding a couple additional place values. On the second page, all you're doing, again, is you're just comparing these numbers like you had been on the previous page. So go ahead, pause the video now, and then come on back when you're done and we'll go over the answers together. All right, let's look at question number 2. Question number 2 asks us to compare 9/10 and 4/10. 9/10 is greater than 4/10. Question number 3 is one of those tricky ones. We have 5/10 and 5/100. These are not equal because they're not in the same place value. 5/10, if you're thinking of our place value chart, 5/10 would be right here, whereas 5/100 would be right here. So 5/10 is farther to the left, which means that it's larger. So 5/10 is greater than 5/100. Question number 4 asks us to compare 24/100 and 38/100. 38/100 is larger. 5 is 49/100 compared to 49/100. Those two numbers are equal. Question number 6, this is another tricky one. I have 3/100 on the left and 33/100 on the right. I'd much rather have 33/100, so 3/100 is less than 33/100. Question number 7, we're comparing 28/100 and 42/100. Again, the place values of each of these numbers are the same, so I'd rather have 42/100 than 28/100. One way that you could solve problems like this is you could always stack these two numbers on top of each other. So I could do 0.28 and 0.42. And when you stack them on top of each other, you're going to move from right to left and you're going to compare each digit. So the ones places are the same. Here in the tenths place, I can see there's a 2 and there's a 4, and I'd much rather have the 4 in the tens place. That is much larger. The same thing for the problem above. I could have stacked 0.03, and I could have stacked 0.33, and then compare from left to right. So in the ones place, they both have nothing. But then in the tens place, I see that 3 is bigger than 0. So 33 hundredths would be bigger than 3 tenths. All right, let's take a look at question number 8. 99 hundredths compared to 9 tenths. I would rather have 99 hundredths. This one, I would need to look at the hundredths place, because on 99 hundredths I have 9 hundredths, whereas over here I have technically 0 hundredths. All right, question number 10. Now we're comparing from, or ordering from least to greatest. So I'm going to have 1 tenth, and then 2 tenths, and then 6 tenths. Question number 3. This is one of those tricky ones. The smallest number that I have listed here has a 0 in the tenths place, so 0.03 or 3 hundredths. Then the next smallest number would be 0.3 because it has 3 tenths, but technically it has no hundredths. And then the largest would be 0.33 because it has 3 tenths and 3 hundredths. Number 12. I'm going to have 0.28 or 28 hundredths as my smallest, and then 0.98 or 98 hundredths. Oops, I made a mistake. I'm going to have 0.28 or 28 hundredths as my smallest, and then 0.89 or 89 hundredths, and then the largest is 0.98, which is 98 hundredths. The bottom question asked me to use a model to compare the following decimals. So you could just use the model that we have on the last page, where we're comparing 0.4, 0.5, and 0.8. On to the second page. We're comparing 4 tenths and 35 hundredths. This one could look very tricky because technically 35 hundredths has more numbers in it, and 4 only has 4. But if we were to stack these two numbers up, 0.4 and 0.35, when we compared going from left to right, I compare my zeros in the ones places, those are the same. Then I go over to the tenths place, and 4 is bigger than 3. So even though it looks as though 35 hundredths is more because it has 35, 4 tenths is actually larger because it has a 4 in the tenths place. So technically that's like saying you have 40 cents compared to 35 cents. So be careful with those problems. Don't let them trick you. The next one is 24 hundredths and 42 hundredths. 24 hundredths is less than 42 hundredths. The next one, again, this is just like the one up top. If I compared these by stacking them, they both have a 0 in the ones place. They both have a 3 in the tenths place. But when I get over to the hundredths place, I can see that 33 is the bigger number. So 3 tenths is less than 33 hundredths. The next one is trying to trick you. If I were to stack these up, 0.8, 0 is the same as 0.8. Because this doesn't have anything in the hundredths place, I could just add a placeholder 0. So those two are equal. The next problem, 0.09 or 9 hundredths and 0.9 or 9 tenths. 9 hundredths is less than 9 tenths. I know that because if I were to stack them and compare them, I see in the ones place they're the same, but in the tenths place I have no tenths compared to 9 tenths. The bottom problem on the left side, 0.27 is less than 0.72. To the opposite side, 6 hundredths is less than 6 tenths. Remember, this one has no tenths, but this one has 6 tenths. 21 hundredths is greater than 12 hundredths. 1/10 is less than 11/10. 79 hundredths is less than 8/10. Even though I know this looks like more, remember this is technically like saying you have 80 cents because there's a 0 placeholder there. 55 hundredths is less than 6/10. Again, it's like there's a 0 placeholder there, so it's like comparing 55 cents to 60 cents. And the very bottom question, 5 hundredths is less than 5/10. As always, if you have any questions, please feel free to reach out, and I will see you guys tomorrow.